let's prove this identity together. Right, what we have here, we have an identity. Remember the difference between an identity and an equation. Okay, an identity, you may even work on the left hand side and right hand side some of the times. Not every time, but some of the identities you may work on the left hand side and right hand side at the same time. Okay, right, what do we have here? We have what? This numerator, and when I see it here, I see the difference of two squares. Okay, remember the difference of two squares from algebra? X squared minus y squared is equal to x minus y times x plus y. This is how we factorize difference of two squares. And then if I check here, I also see that we can use reduction formula there. Right, if we look at the angle 180 degrees minus x, which quadrant is it found in? It is found in quadrant 2. This is angle x, acute angles there, and then 180 degrees minus x. This is from 0 to 90 degrees, and then 90 to 180 degrees, 180 to 270 degrees, and then 270 to 360 degrees. Right, and then this is quadrant 2. That's where we find angle 180 degrees minus x there. And then here 180 degrees plus x, and then here with 360 degrees minus x. Right, and then remember that in the first quadrant, all the trigonometric ratios are what? Positive. And then in the second quadrant, it is only the sine of angle that is what? Positive. And then in the third quadrant, it is only the tangent of angle that is what? Positive. And then in the fourth, it is the cosine of the angle. Okay, right, so now so it means we are here in the second quadrant. Okay, what are we going to get? Okay, sine 180 degrees minus x is going to be what? Is it going to be negative sine x or positive sine x? Okay, it has to be positive sine x. Okay, right, and then we come here. So now we have applied our difference of two squares here. We've done our reduction here. Do you see that? And then what we have these same brackets. We can say sine x minus cos x divided by sine x minus cos x divided by sine x minus cos x divided by sine x minus cos x, which is z, which is 1, not 0, 1. Right, and then it reduces to this. You see that? And then what we have here, if you look at this part, we have a fraction. And then we're applying our knowledge about what? Addition or subtraction of fractions here. Remember, even from the numerical fractions, if you say 3 over 5 plus 1 over 5, this equals to 4 over 5, isn't it? You just add the numerators. If the denominators are the same like this, you just add the numerators or subtract the numerators if you're subtracting. So here we have to make the denominators to be the same. Then you can just simply subtract our numerators. So here is going to be sine x plus cos x over cos x minus 1. 1 is like 1 over 1. And then what is our lowest common denominator here is cos x. So we're going to multiply this one by cos x and then multiply this one by cos x. So it becomes what? It becomes sine x plus cos x over cos x minus cos x over cos x. Cos x divided by cos x is what? Is 1, isn't it? Right, now our denominators are the same, so we can, oh sorry, this minus is not clear. Let me write it here. Right, so the denominators are the same here, so we can what? We can subtract our numerators. So it's going to be sine x plus cos x minus cos x over our denominator LCD, lowest common denominator, which is this. You see that? So that's what we're supposed to do there. And then we're at this step now. And then if you check here, positive cos x minus cos x, what is it? This is 0. Okay, this is 0. So we remain with sine x over cos x on the left hand side. You see? Okay, I've been writing my right hand side also. You see that? You see that? You see that? Okay. And then at this stage here, I can use the identity that says that tan x is equal to sine x over cos x here. Okay. And then I can write it like this. Or even I can say this one is equal to tan x and becomes tan x is equal to tan x. Then we prove that the left hand side is equal to right hand side. Okay. We're going to meet in the next question.